Good afternoon, everyone. At least it's afternoon here. Whenever you watch this, I hope at least that you're kind of doing well. Recently, I've had the opportunity to help different units within my organization implement these things called service level objectives. The experience has been great. It's been really fun, actually. And the organizations are, I believe, at least making much better and much clearer engineering trade off decisions as a result. But through this, there's been a familiar series of questions or challenges that have come up for each organization. Today, I want to help you sidestep these challenges by talking you through service level objectives as well as, in practice, what they're suitable for. Later, if people ask, I'll also publish some guidance on kind of a practical example as to how you can implement a service level objective in your organization. Now, most of my experience with service level objectives or just SLOs has been at Zalando. Zalando started with SLOs at about 2016 and has been on this evolving path to try and improve their effectiveness ever since. You can read more about that. There's a really excellent article on this topic by a former colleague of mine, a guy called Pedro Alves, on the Zalando engineering blog. I'll link it near to wherever it is that you found this video. The journey hasn't been smooth, and the organization's handling of SLOs has required kind of enablement with engineers and managers and product colleagues and executives. You can learn more about how we use these in practice by watching another video, a video from a conference called SLO Conf, which I'll link together with the engineering blog. This video in particular is designed to try and boil down that like 7-year journey into something that you can practically leverage within your organizations. Let's start though at the start and talk about really what is the fundamental challenge of managing engineering organizations. Now, when leveraged correctly, engineers can produce software that really fundamentally change the economics of a business. See, they either dramatically reduce the cost of some sort of required business operation, or they not expose the business to new markets, especially internet-based markets. However, engineers are some of the more expensive colleagues to hire, and the talent pool for engineers is still limited. Additionally, for any given software, there's kind of a hard limit on how many engineers that you can add before the amounts of work required to coordinate those additional engineers outweighs the capacity, the increase in velocity that a single engineer will add. Those of us who are responsible for the engineering time of either ourselves or other people really agonize over the question, how do I spend my engineers' time to benefit the organization as much as possible? Even if we have unlimited engineering time, and engineers work as more than kind of adding new and exciting user features to our product, they also need to ensure a whole series of these non-functional requirements. These are things like making sure the software continues to work as expected for users, especially when user demand changes or when a new feature is released. The software remains secure as new vulnerabilities are discovered in either the software or the underlying libraries. The software itself is sufficiently clear and straightforward, so as we have a new colleague that's being onboarded into our teams, that colleague can effectively contribute quickly. Lastly, that the software runs efficiently, so that the business pays kind of as little as necessary for the underlying computing. Different organizations need to make different trade-offs depending on the kind of position that they're in at the time. A startup might care less about reliability or cost than it does maybe about implementing a significant new set of features required to onboard a new and exciting customer. The question is then, how do we split our engineering capacity amongst these different tasks? We could choose it based on a kind of recent import or a managerial decision or kind of a gut feeling, but there's a better way, a way through data. To establish a framework to govern engineering time, we need to be able to kind of measure the value that we get out of different kinds of engineering work. The deciding factor for where we spend that engineering time ultimately is a critical business metric of some factors, so financial return on investment or reduced risk of financial loss or customer lifetime value or just customer engagement. To switch to reliability work, we need to be able to demonstrate what the current level of reliability is, as well as what the likelihood and business cost of future unavailability will be. The best way to do this is to measure the availability of the customer experience, but do it as close to the customer as possible. This could be at the edge of your software system. Maybe you have an API gateway at the edge if you don't own the client device or app. Or if you do actually have an app on device, measure that experience directly in that application. Measure your experience in segments that are meaningful for the business. We frequently use a customer operation, something like add to cart or place order. Each of these measurements becomes what we call a service level indicator. Now, invariably, you'll spot periods in which your reliability drops. Take a look at what happens to these critical customer metrics, this engagement or this financial loss, during and immediately after these periods of unavailability, and just see how much you're losing as a consequence. Keep track of it for maybe 60 days, for example. Write a report to management making it very clear what the cost of unavailability is and what the difference in cost would have been should we have kept better levels of reliability. At this point, you're armed with data, and the next step is to work with management to really make that data actionable. There are two things that you need to establish here. The first is the target, and the second is the culture. Now, the first thing to do is to recommend a specific target that, based on the data that you've collected, is achievable without needing to sacrifice too much product development or some other critical business deliverable, but that will positively impact the customer experience and those core business metrics. The target is the actual service level objective. The hint's in the name, it's our objective. It's often easiest to pick a number that's kind of similar to the median historic availability. Just be available as you are kind of normally. Suppose you've suffered some major issue in the last 60 days. We usually have. There will be a difference in the median availability and the mean availability. That means that the target that you are setting already needs you to spend more time on reliability work. It's often easier to sell this to management to try and continue to achieve what you already kind of on average achieve already, and just fixing those outliers, whatever they are. From a management perspective, this limits the maximal investment required. An SLO is usually expressed over a period of time. For example, let's say we'll have blah operation, and that will have an average availability of 99.5% averaged over that 28-day period. Now, the second and frankly much more important thing to do is to establish a routine of reviewing the service level objectives with your management or engineering planning stakeholders and really using them to prioritize work to improve reliability. After all, that's the heart of the challenge that we're looking to solve and the very purpose that we designed a SLO for. It's also the part that, for whatever reason, I frequently see engineering stakeholders skip. The error budget is the best metaphor for understanding when to prioritize reliability work over every other kind of work. It is essentially 1 minus the SLO of the service. So let's take the example. Let's assume we have an SLO of 99.5% on our operation. We say that we have a 0.5% error budget. We fully expect to spend that error budget each month. We might consume the error budget by creating an error during a migration or some sort of unexpected failure, a bad deployment, or basically any other issue that carries technical risk. So long as we remain within that box of that 0.5% error budget, we don't need to add any more capacity to reliability work. If we exceed that 0.5% error budget, we need to shift our engineering allocations to prioritize reliability work until the SLO returns where we expect. We need our management stakeholders to agree and really buy into this direction. Ultimately, they are the ones who are both accountable for and drive our work, and fundamentally, they need to understand the value of this approach as well as build a culture where this is respected. Okay, so let's assume that we have managerial blessing on our service level objective approach. This is no small feat, by the way. Congratulations to us. The next thing that we need to do is figure out really how to take action based on this data. Now, an SLO's error budget can be quickly exhausted by periods of complete unavailability. Let's call this a fast burn mode, as well as an issue that kind of slowly leaks availability, a slow burn mode. They need different controls in order to take action. For a fast burn mode, the best thing to do is to set alerts on the burn rate of the error budget, and whenever that happens, forward that alert to an on-call team member to really take action when they're received. Google has already done some really excellent work presenting the math of doing this efficiently. The key takeaway for the purpose of this conversation is that you should treat this as an emergency or an incident and prioritize fixing it above all other work. For slow burns modes, there's kind of far less urgency to the response. A slow burn issue will mean that the error budget is exhausted, but it will take many days or even weeks to do so. It's most frequently introduced in my experience due to some deployment an engineer made that maybe they didn't pay as much attention to as they should have. To catch these, we can rely on that same math that Google provides, but let's take a much longer window, or we can periodically review a projection of the SLO and what it's going to be linearly by the end of the period. If the SLO is projected to go outside its budget, we take action. If not, we continue just making the same trade-offs that we're making now. So that's it. Recapping, determining where to spend the engineering time is really at the heart of any modern, especially internet-based business. Service level objectives, or SLOs, are really invaluable tools for helping us moderate where we spend that time clearly and objectively, moderated by the actual value of reliability to the business. We need to work hard to make sure that what we measure is critical for the customer experience and correspondingly for the business to work, rather than measuring maybe what's easy. We also need to work to establish the value of reliability by establishing the loss in its absence. If we do this, we can work with management to set a culture where work like this is really prioritized and set routines for both these fast and slow reliability challenges. Frankly, this results in us getting much more done with much less discussion. Thanks for joining me today. I hope you found this video helpful or at least mildly entertaining. If not, that's fine. Maybe you found it educational. If even that didn't work, frankly, I feel terrible and I'm kind of sorry for wasting your time. Maybe next time it will be better. You can find out by hitting that subscribe button and really joining me on this kind of knowledge sharing journey. You can help me improve by telling me how to improve directly in the comments below. Just be direct. Thanks, people. I hope you have a good, well, whatever time of day it is. The internet is a weird place. See ya.